Hello my friends. Okay, so today we have much bigger fish to fry. Look at this beast. So this is APC Surge Protection 700 VA backup. So it served me well for quite a long time, but now it just said battery is gonski. So let's take a look what we can do. Well, first of all, battery looks like it's very nice compartment right there, so this is really awesome. So battery can be just replaced, but like I don't just like fixing thing easy way, so I like to also take a look what's inside. If this thing already giving me some grief, like I would like to explore it and see what's inside and take a look what kind of battery I can use. Obviously I can use this original, go and buy original battery. It looks like it's about the same price as this thing, so it's like, yeah, ridiculous. So I decided to open it up to see what can I hack around, and I actually do have a battery which is completely incompatible, but maybe it will work, and we try together with you to power it up. So if right now I plug this thing in, it will just keep beeping saying battery is not good. Let's just plug it up, but to illustrate the purpose, yeah, that's how it beeps, indicating that battery is bad. Here we are, it's blinking this red thingy here. Very annoying sound. And maybe it wasn't the best idea to actually energize all these jars before I try to open it, but I'll try to be careful as possible. Alright. So first let's just unscrew that. Alright guys, I unscrew all those 6 screws, but at the same time I decided to pull a battery out because some of the screws were right here. And look at this nasty surprise. What the hell is this supposed to mean? I've never actually seen UPS battery pop like that. This is actually nuts. I am surprised. What kind of battery is this? Is this like a sealed non-spillable lead acid battery? Battery must be. How the hell is this possible? Like I swear this thing was stationary, sitting on a under my desk for like 7 or 8 years. I forgot by now. Probably 8 years. Like there was no one throwing this battery around in order to actually, I don't even know. Wow. What the hell? And I'm kind of like, where is the, like, is it spilled over all this unit? Like I'm gonna open it and see if the freaking acid spilled over the unit, but it seems to be operational, so I assume it didn't. But okay, I'm a little bit shocked, sorry, let me collect myself. And if anyone's seen anything like that, when there is a genuine battery cracked like that just out of blue, being regularly used, not abused, sitting on a desk, under the desk in some proper like household condition, like, you know, plus 22 degrees C, not overheated, not thrown around, not stepped on, whatever, you know what I'm talking about, right? It just cracked like this. This is like, I think it's like a safety hazard. I'm lucky if the acid did not leak all over the place, even if it's sealed. Maybe it has some extra bag, because I see some white stuff poking through. So what the hell is that supposed to mean? Anyways, hello APC, hello, I'm gonna talk to you about this, yeah. Anyways, I put this thing aside. Oh wow. Oh wow, that's okay. So I already obviously unscrew all this stuff, and now obviously this thing is way lighter. The battery weighs a ton. Okay. Looks like I don't see any like juices and corrosion, so hope I would be able to pull this out. Yeah, looks like it's still alive. Like I don't see any kind of corrosion and nothing like that. So there's some bugs and spiders here. Nice. Cool. Alright, obviously I have to dig or dive a little bit further in order to let me take a look first on the capacitors and try to discharge them just to make sure I'm not gonna fry myself. Okay, let's get a bit closer. So what do we see here? There's a whole bunch of connectors which I like a lot. This is the way it has to be implemented. All this is connected. Okay. So here we are. This is the, oh my god, I cannot even fit this into my, okay, try this. Look at those big chokes, chokes, ferrite cores over here. Or like here, here, and here. It's very nicely done, I guess. This is to suppress all interferences. Okay, so this is our input cable. Okay, this is some sort of interface board, I guess. Those are just buttons here. Yeah, there is nothing special, those are buttons. Yeah, I also would like to look into this module. What exactly, how this protection exactly is done. It's like it's cable in, cable out. I'd like to see how that done. I'm gonna get into this a little bit later. There is also, what is this? This is fuse probably. Yeah, this is, I guess this is resettable fuse over here. Awesome. There are 3 bars over here. The wires just soldered straight into them. Okay. And they are going just parallel, just like that, and everything is soldered. I think the 2 of them, 2 contacts over here, I think they are just run from the mains. They never actually go over back up, but this side over here goes through the backup, as you see. So this is probably backup wires. There's also some special feature is like main power detection. So this orange, I think this is master. Yeah. So if this master is powered, all this side, like this side, will be powered as well. Oh, sorry, I'm wrong. This is controlled by master. So if this master is powered, this will be powered as well automatically. It's very nicely done. Okay. And obviously this looks like that is, this orange wire is sort of like powers the master. So it goes specifically to over here, orange and brown. So as I understand, the green ones is just the common ground. It's common like everywhere. It comes from the outlet. Okay, blue is a neutral for backup system, orange is for master, and brown, I guess, is for everyone else. Okay. Okay. Alright, okay, let's take a look. I will try to unplug the board, because there is not much going on this case, and so lots of things going on the board. Okay, this ones. The spade connectors are usually hard to detach. This one. And this is the main input. It's even harder. Oh my god, this is sticky. Oh, yuck. Okay. And okay, all right, we freed the board. I'll come back to this later, but not much going on really here. Okay, here is the board. It is so cool. So let's take a look at this printed circuit board. So first of all, let's start from the input side and the high voltage AC side. So we see here CLC input filtering, there is a lot of protection on this side, and some of the protection even possibly could be for output, because these 1, 2, 3 are input pins, and this one they are to feed. There is this one also as well, to feed our devices which are supposed to be under uninterruptible supply. Also, we have 2 relays over here. One of them, I think, we have 2 relays, one of them switching device outputs, another one, I think the usage of a second relay is to sense that the master, remember I mentioned you the master plug, and also switch on and off devices which are controlled by the master. I think this is why there are 2 relays. And this one is quite beefy actually. So this one 16 amp 240 volt VAC, so this is quite beefy relay. I think this one is not as beefy. Let me see what it does. It say 12 volt control, but there is no specs in terms of like what it can switch. Yeah, 8 amp 250 volt. Yeah, so this one is a bit more beefier. So I don't know which one specifically is used, but for what exactly purpose, it's hard to trace. Yeah, but this is my guess. But also another thing to note, take a look at the amount of transformers over here. 1, 2, 3, 4, 5. There is 5 transformers, bunch of, this is essentially a input filtering, but this one and this one, this sort of a coil, but it is a transformer essentially. There is one winding over here, another winding over here, 2 windings, so this probably acts as a transformer in a toroidal core. So yeah, it's really hard to tell which specific transformer corresponds for what, but I can just assume that this one is main switching transformer, which actually feeds like 12 volt from the battery, chopped with high frequency, and outputs 120 sort of AC driven by those MOSFETs, judging by their bulky radiator over here. Obviously those are actually bulky, they keep heat in them. There's all of them actually like that. There is no fins, so that's to keep heat. This is just thermal, to have a thermal weight, that's it. Some of the transformers supposed to be for the standby mode. Some of the transformers supposed to drive feed actually logic here. So by the way, speaking about, here is the already pulled the little something here, and this one ST microcontroller 76. Shit, I forgot the label. It's really hard to tell. Anyways, I put the description. But this is 8-bit microcontroller from ST, and it's not ARM. It's just their pretty old microcontroller, because I can't even get the proper spec sheets for this. But it's like 8-bit. It has USB host, and it has some basic 8-bit ADC, and it has I2C, SPI, and things like that. This little dude is 93C46WP. Is actually 1 kilobyte, 1000 byte EEPROM. Yeah. 2 op amps over here, ST. This little dude is a voltage reference from TI. It's nice. There is a few more little thingies. This transistor, another transistor. Yeah, those are not IC. By the way, there is a whole bunch of optocouplers, like 1, 2, 3, 4, 5, 6, 7, 8. Crazy, but yeah, I mean, there is also I think this is one rectifier over here, probably somehow connected to this one. There is also 1 amp polyfuse, I assume this is over here. This is a very interesting device. It reads TNY268PN. Apparently it is kind of switch which used for standby mode, for charging circuits. It's a very interesting specific device from, I think, power Power connection, a power electronic company. It's not that well known, but very specific, purposely built. It has a MOSFET. It has protection over current, over short circuit protection. That's a very interesting device. I assume, by judging by the close proximity to this transformer, they are in this capacitor. This stuff works together. Potentially with this rectifier, maybe they do standby circuit like this, because this chip is used for standby circuits a lot. What else is interesting? Also, take a look at this. So this device, this UPS can also protect your data lines like Ethernet, I guess, and telephone lines. There's an in and out, and judging by the close proximity of those 1, 2, 3, 4, 8 diodes, so I think they are part of. I already tried to trace it, and I think this is part of the protection. I'm not sure how exactly it works, but I think many of them are just to the ground, so I'm not sure. Yeah, and those MOVs are as well part of the protection. There's also spark gaps here, like 1, 2, 3, 4, 5, 6. I don't know why it's 6. I think there's 8 pins on this connector, or here there's only 6 spark gaps. There's one I can, yeah, oh, whatever, but there's 8 diodes, and they are clearly connected to those diodes. There's a microcontroller, and there is also data output port. So this thing technically can output data to your computer, probably telling computer to shut down when their battery is getting really low. Shut down safely. 24 MHz crystal, some peripherals. So this microcontroller process all the button clicks and stuff like that, which are on the main. There is a ribbon cable goes to the main panel. There are a few buttons there and some LEDs. This dude is the switching. Geez, I forgot what is that supposed to be. It's another switching regulator, voltage regulator from ST. I will again include the specifics on this dude. Over here we have pulse width modulated controller from TI. Yeah, I think this is to drive actually the whole circuitry in order to generate 120 volt from this. It's really, again, it's I just assuming that's what it does, because that's a really complicated schematic, and I'm not an expert. I just did some more or less research. Okay, what else? 2 capacitors, but this one I'm not sure, really hard to tell. It's wrapped in a shrink wrap. This one is 35 volt capacitor, I think. 3300 microfarad and 25 volts. So that is not high end, it's low end. 25 volt another capacitor. I don't really see high voltage capacitor here at all. So what is this dude? Oh yeah, here we are, 400 volts. So this is high voltage side. So and charging circuit doesn't have to be super beefy, because this dude charging battery is really slowly, so it discharges them quickly, hence those super beefy heat sinks over here, or bulk heat sinks. And there is not much. I think this is like charging circuitry, because this, by the way, this AC controller or converter, it also can be used as part of the charging circuitry, and part of its circuit there is also optocoupler. If you look at, I'll include datasheet in their supply datasheet, you can see that part of the circuit is optocoupler. I'm not sure why I need that many. Yeah, that's crazy. Like, that's, yeah. But there's also 1, 2, 3, 4, 5, 6, 7, 8. Aha, wow. Is it like 1, 2, 3, 4, 5, 6, 7, 8? Yeah, I need to do research. Maybe there is something, because there is a corresponding number of these MOSFETs over here to the amount of optocouplers. Interesting. What the hell that's supposed to be used for? That's interesting. Oh, my bad. those are 1, 2, 3, 4 MOSFETs, and those are diodes. 4 MOSFETs, 4 diodes. So yeah, I'm not sure 8 optocouplers, what they use for. I will do a little bit of research, and I will include, if I figured out, I will include it into this video. So on the discharging side, right? So there is charging side, then it has to switch into discharging mode. There is a 3 30-amp fuses. And they are, I think they are all together. Yeah. So they're all parallel, essentially running at like 90 amp fuse, I assume. I'm not sure if this is sort of weird, but that's a weird combination, really. Yeah, probably it's interesting that they didn't use like a 90 amp fuse or 100 amp fuse. They use 3x30, because if one goes, obviously it's gonna increase the current, and like all 3 of them gonna go. So yeah. What else is here? There is a port over here, so I assume that's potentially debugging port to debug this dude, but because this is not ARM, it's probably quite unfamiliar to me territory. I don't know what kind of platform it is. Like, is it ARM, like MIPS or whatever? So yeah, I can't even like poke around. I don't even know if there is a serial here. It could be some sort of proprietary debugging shit from STI. Actually, I do have a STI debugger. Who knows? I can just plop it in to see what's gonna happen. That's majorly it. I don't know what else I can comment. I will try to look. Maybe there is some sort of schematic someone done to you know, to actually know a little bit more details about this specific charging part, and about specific part which actually generate sinusoidal for 120 volt output, AC output, yeah. But that's all I can say, actually. Another, my comments about capacitors. Looks like those capacitors are all over the shop. They are, I think there is 4 or 5 different brands, if not 6. 1, 2, 3, it's same brand. This is different. This is different. This is even different. This is different. This is yeah, 6. No, this, I think those are the same. And this one, really hard to tell. Looks like some sort of bluish. So yeah, maybe similar to this one. All different brands of capacitors, which is just sort of like hilarious. Looks like they didn't bother, and they just went to the Shenzhen market and bought whatever is cheapest that day. But it seems to be working, seems to be okay. I still cannot understand why the battery broke down. Yeah, anyways, so this is roughly the part, electronics, major electronic part over here. I'm not sure, this is actually line break or line fault, whatever it's supposed to mean. I didn't look into documentation. So yeah, and to look into this one. Also would like to see how good is the sinusoidal out of this thing. It's separate, maybe video, or maybe I'll do it at the end of this video to just, you know, hook up my scope when it's running off battery and see what exactly its outputs. Yeah. So now we have last thing to do is just actually put it together. But ta-da! I have this. Okay, I'll just move this away. I just happen to have a spare battery. I'm not sure if that's gonna be good replacement for this, because this is like nowhere near for, it's not designed, it was designed, I bought it, was a completely different project, right? So hence I'm not super keen to actually replace it. By the way, this one is heavier than this one, I'm not sure how much, but heavier. So maybe capacity of this battery is shittier, but it's still 12 volts, 7 ampere hour. As far as I know, the original battery is 9 ampere hour or thereabouts. Charging current, it says 2.1 amp. I hope it's in that ballpark range. I'm gonna measure it. I hope I'm not gonna shock myself when I'm going to do that, but yeah. Alright, so let me put this all together and see what we got. Look, and I powered this thing off. I have to be very careful because it's a high voltage stuff around here. And let's take a look what's the voltage on a battery. 1328, looks like it's charging. Unfortunately, I can't test the current because I have blown 10 amp fuse in this. Look, so I don't have a replacement at the moment, so I won't be able to check the current. I completely forgot about this, so I will replace the fuse and I double check the current. But as right now it seems to be it's working okay. The only and one test which is left to do is to actually pull the plug. It seems like behaving as usual, and obviously there is no load connected to it at the end of story, so cool. Okay, let's put it all together and run some simple tests and we'll see what we're gonna have. So after a bit of poking around, we finally put it all together, screw everything in, and let's just slide this little nice cover. Ta-da! So we have it. Let's power it again. Guess it's charging or something. Yeah, it's not bad. It's working. I'm gonna also test it with some sort of light source. I don't have anything handy at the moment. So yeah, looks like we have our backup back together. So that was very easy to actually replace the battery, providing you have the right battery. You can probably put smaller battery and which is gonna provide you way less capacity, but better to actually use the original dedicated battery for such purpose. But whatever, I just happen to have the battery which actually fits exactly right here, and probably a little bit less capacity, but I'm not gonna use it to the full power this thing is capable. Also, it was actually quite nice to take a look how the UPS made, and some extra information which I discovered and some data sheets I will gonna include in the description of this video. I think that's gonna be it for now. Looks like we have a successful restoration or revival of this Back-UPS ES750. It's a success video. And guys, if you like this sort of videos, please subscribe, ring a bell, throw a suggestion, and see you next time.